So thank you, Dale, for that really wonderful, lovely introduction, for all your warmth, and really for all you do to make intellectual and civil discourse flourish. I think we can all agree that there actually could be nothing more important in this crazy time. So I think we should give Dale a round of applause. And thank all of you, familiar faces and new friends, for being here today. I'm really grateful for this warm welcome into my newest leadership role, really, which is a natural extension of my tenure at the helm of Hunter College. For over 2 decades, it was an incredible pleasure working with many of you here. We truly enhanced public higher education in New York City. At Hunter, which was the largest public college in New York City, we championed advances in science, research, and healthcare, and focusing on how to make the world a better place through excellence and access. And now I have the great honor to move NYSIF, the New York Stem Cell Foundation, into a new chapter, focusing once more on improving the quality of our lives by translating cutting-edge research into cures. So today, I'm so grateful to have this opportunity to share with you some of the breathtaking NYSIF research that is truly breaking boundaries of science and medicine to combat some of the most pernicious and intractable diseases of our age: diabetes, multiple sclerosis, cancer, macular degeneration, Alzheimer's. There is no disease beyond our ambition to research, arrest, and ultimately erase. While we live in deeply troubled times with tragic conflicts in our world, today I urge all of you to embrace my optimism about the future. Optimism based on the recent extraordinary and dramatic advances in science that we all see. The potential of this field to radically improve the quality of our lives is simply unparalleled. And that is why all of us at the New York Stem Cell Foundation walk into our labs and offices every morning with a sense of enormous hope and urgency. Here's why we see such potential in our groundbreaking work. Simply put, stem cells are a miracle of science. From a scrape of your skin or a small tube of your blood, we can make your stem cells. And from your stem cells, we can create any type of cell in your body with your own genetic makeup. You'll see on this slide, there's a picture of a doctor, Dr. Shinya Yamamaka, who discovered this technique of making stem cells from blood and skin in 2007, and very well deserved, received the Nobel Prize in 2012. And his work has allowed us to do stem cell science removed from the politics that many of you will remember when stem cells came only from embryos. So let's think about this. We can recreate any cell in your body in our lab. We can create your heart cell that beat in a petri dish, a brain cell, an eye cell. This is a total game changer for how we understand and treat disease. In traditional drug discovery, drugs are initially tested on mice. We hear about that all the time. But people are not mice, and mice don't get Parkinson's or Alzheimer's. Now, this sounds very obvious, but it's truly an important fact to grasp. With stem cell technology, we can actually test drugs and do disease modeling on actual human cells affected by that disease. And with this, we can cut years and billions of dollars from the traditional lengthy and expensive drug development process. Take Alzheimer's. We don't extract a brain cell from someone suffering from Alzheimer's. So only after they passed away can you study their brain cells. Now, clearly, this has slowed our understanding of this disease, but not anymore. At NYSIF, we can create stem cells from a simple blood draw of someone suffering from Alzheimer's and turn those stem cells into their brain cells. So we can see what Alzheimer's and Parkinson's and MS look like in a dish at the cellular level. And we can watch the disease progress in that dish and continue to learn. And even more significantly, we can test compounds on those diseased brain cells to discover which drugs might make those cells healthy. So think about that potential for cures. Pushing the frontiers of disease research, we are also using stem cells to create new, healthy versions of your damaged and diseased cells. And we aim to transplant your own healthy cells that we've created in the lab back into your body. And that is what we mean by regenerative and personalized medicine, which is truly tomorrow's medicine. Now, what makes NYSIF unique in the use of stem cells? It's that we have developed an automated robotic production system that no one in the world has. Why is this critical? Stem cell lines were typically created one by hand over a period of several months, really through a graduate student and artisanal process. Now, it's great, we all love artisanal bread and furniture, but it's not top quality science to test drugs on handmade cells by different people of varying quality made with different techniques. To have meaningful drug discovery, we need thousands of cells that reflect the diversity of our population. So NICE conquered the challenge of increasing scale and diversity and eliminating human error in production of these miracle stem cells. Our revolutionary robots create stem cells 24 hours a day, 7 days a week, at a scale that allows for meaningful drug testing. And because our large bank of stem cells come from ethnically and genetically diverse people, so great to be in New York where everybody is and we can get these samples, we know we're going to move the needle in health equity by including all populations in our drug studies, making up for generations of research neglect because one size cure does not fit all. And if you think about, you always hear women being left out of studies, different ethnic groups. With stem cells, collect a blood draw, have a library, a biobank, and we address this problem of not reaching all populations. So with our automated stem cell platform, we can experiment with new compounds at the very beginning of the process on the human cells that are affected by the disease. And this offers the potential to make clinical trials more effective. But think about it, you're cutting years and billions of dollars from the traditional lengthy and expensive drug development process. This one-of-a-kind technology, coupled with the potential of stem cells, really makes us confident that our grandchildren will look at Alzheimer's, diabetes, and other diseases the way our generation looks at smallpox, as diseases of the past. Our work has become even more powerful as we deploy artificial intelligence to pioneering robots. When you hear about AI and drug discovery, this is what we're doing. And AI, somewhat controversial, it's making a difference in drug discovery. We've partnered with Google to examine Parkinson's cells. We use AI to see cellular mutations that you and I could never see. So you're looking at things that we could never have seen before in a disease in a cell. And so now, having those cells and being able to see the structure of a disease, we're testing drugs, particularly in Parkinson's, to find a cure for this debilitating disease. Last month, we're really, really proud to announce our first major collaboration with a pharmaceutical company, Johnson & Johnson to be specific, using our proprietary technology, which is a really exciting moment for NICEF, because 20 years ago, we set out to show that stem cells would accelerate cures. And Johnson & Johnson just made a multi-million-dollar bet that we were right. So we're now testing their compounds on our AI stem cell platform, which will expedite trials to cure neurodegenerative diseases. So over our 2 decades, NICEF has moved from biology to biotech and to tech bio, and we're continuing to push the boundaries of science. So let me tell you about some of the groundbreaking work we're doing in different diseases. We work in partnerships with major universities and foundations and serve as a link between academia, which can be sort of more basic work, and pharmaceutical, where the end game is making the drug and making the money. We're a bridge. Let me start with type 1 diabetes. Now, NICEF was actually founded by moms who knew that stem cells were the key to curing this terrible chronic condition affecting their kids. They were determined to make sure that stem cell science moved ahead, notwithstanding, you all recall, the first Bush administration's banning of federal funding for embryonic stem cell research. That was a time the Japanese scientists had not found a way to do stem cells yet from blood and skin. It was all about the embryo, and there were huge political conflicts, and the federal government would not fund this research. So these moms stepped in. They raised an extraordinary amount of money to push forward this embryonic stem cell research. And they really funded, they funded what the government refused to do. Now, as you all know, type 1 diabetes occurs when beta cells are destroyed in the body and the body stops producing essential insulin. But because, as I said earlier, stem cells can be turned into any cell in the body, given our and our colleagues' investment and determination, scientists can now create beta cells in the lab that could transplant back in the body to begin producing insulin. And this is happening. So I like to say there was no surprise that the moms were right. They were going to get this done, and they did. A US pharma company called Vertex and a Chinese company have in the last few years transplanted beta cells made from stem cells into a handful of patients with type 1 diabetes, and the patients no longer required insulin injections. It's just truly amazing science. Unfortunately, we still have work to do to eradicate this disease because, as you know, diabetes is an autoimmune disease. So even though we're making new beta cells to produce the insulin, our body is still attacking them. So now, in order to stop the attacks, patients have to be put on a large dose of immunosuppressants, which unfortunately they can often not tolerate. But we are really still optimistic. Along with researchers at Columbia, Yale, and other major institutions, we are working to camouflage the beta cells. We make them from stem cells, and to trying to find ways in the labs with genetic engineering to gene edit these cells to make them invisible and trick the body's autoimmune system. We are also leading the way in understanding the causes of type 2 diabetes, and are truly honored to partner with some of the country's leading type 2 researchers, the former NIH director, Francis Collins. Dr. Collins, who I had the pleasure to work with at Hunter, sought us out, he told me, at NICEF because we have this unparalleled capacity to produce large quantities of high-quality stem cells with automation from this very wide group of people with different genetic makeups. So together with this automation, we've taken it one step further. At Dr. Collins' urging, we are the first people to automate the production of pancreatic organoids. So on our robots, we are making mini pancreases that allow us to take a really close look at the complex mechanisms behind insulin production. So with all of these cells, we make a little pancreas, and we can study type 2 diabetes to decipher how genes influence the body's ability to create these beta cells and maintain the critical supply of insulin. Our most extensive work, which I touched on a little earlier at NICEF, has been focusing on moving the needle in neurodegenerative diseases. So one of the major challenges in studying Alzheimer's disease is the inability, as I said, to study live brain cells from people with Alzheimer's. What does Alzheimer's look at? But now we can make neurons in a dish from the blood or skin of an Alzheimer's patient. So let me tell you about a really fascinating study we're doing with Harvard and Rush universities. They have been following the health of a very large group of nuns and priests over decades, collecting both clinical and psychological data. And my assumption is they pick this population, they often live together, they often live clean lifestyles. So this is sort of the perfect science group to study longitudinally for years and for really decades. We made the stem cells and then brain cells from a subset of these priests and nuns who had Alzheimer's disease. And when this group passed away, we were able to do a post-mortem on their brains and a comparison of their actual brain cells from people with Alzheimer's to the ones we made in the lab showed they were identical. So this was true proof of concept for us that we can observe Alzheimer's and other neurodegenerative diseases in a dish while the patient is alive, and then test drugs on these cells to see if they can halt or even reverse the effects of this terrible disease. Now, because individual genetic makeup influences each disease, NICEF is contributing to research by creating this extensive library of stem cells from patients of all diseases and ethnic backgrounds. So we're very proud. We have the largest collection in the world of people with a particular kind of Parkinson's, GBA, which is very severe, as well as a very large collection of different people with different genetic makeups who have LRRK2 Parkinson's. So if you think of it, we're basically having a study of hundreds of people in a dish, in a laboratory, bringing drugs in, putting them on the cells, using AI to see, can we put that drug on a cell and move it from looking unhealthy to healthy And what can we learn about that compound that can turn into a drug? We're doubling down also on our research in multiple sclerosis, MS, which you know is a neurological disease where the body's immune system mistakenly attacks the nervous system. Now, again, because we have one of the largest collection of MS patient stem cells, we know we can really push the knowledge. And already from these stem cells, we've built replicas of the human brain. Again, brain organoids, a few types of different brain cells put together to represent how the brain works. And we have an unprecedented window into how this terrible disease progresses. And what we learned from these multiple sclerosis mini brains is a really remarkable discovery that MS patients have significantly few brain support cells, which are responsible for reducing a protective myelin coating, which gets lost in MS. So with this discovery, we see that MS, yes, it's an autoimmune system problem, but it's also a dysfunction in the brain cells that we can see in this mini brain, and that opens up to new ways of looking at new therapies that we can bring together to protect and repair the brain. Our work in understanding another brain disease, post-traumatic stress disorders, PTSD, is really interesting. We're using stem cells in this very creative way, working with the Bronx VA hospital. So we've made stem cells and then brain cells, neurons, from 40 different veterans, all of whom experienced a very similar and horrific battlefield trauma. Now, 20 of these veterans returned home with diagnosed PTSD, and 20, having seen the same really horrific battlefield experience, were not afflicted by the disease. So we asked, could examining their brain cells explain why some suffered from PTSD and some did not? And it turns out it's looking like the answer is yes. So we mimic the impact of the battlefield on the cells by exposing brain cells to hydrocortisone, which is a hormone that stimulates the body's fight or flight response. And we saw that in the cells of the veterans who returned with PTSD had a much more dramatic response when we stimulated them with this hormone. And that really suggests that a soldier's genetic makeup could make them more susceptible to getting PTSD. So think of the implications. Do we develop policy to genetically screen soldiers before we set them into battle to minimize the number who develop this terrible disease? Or do we use this knowledge to try to cure the disease through genetic engineering of the cells? And the Department of Defense is now funding our next phase of research, which can really only be done through this stem cell technology. To advance an understanding of the causes of autism, we've created the stem cells from 300 people with this condition. And through the generosity of the Simons Foundation, these cells have been distributed to universities around the globe, where researchers are now able to analyze the biological underpinnings of autism, which has been such a stubborn disease to get a handle on. Another really tough disease, ALS or Lou Gehrig's disease, is a disease where stem cell research has really led to critical advancements, and we were very excited at NICEF to fund some of the early work in this field. So we're finding that stem cells derived from ALS patients we can model the disease and see how it progresses at a cellular level. And in both the US and Japan, they found drugs, particularly an epilepsy drug, that has been applied to these cells and has shown the cells change from this unhealthy ALS state to a more healthy state. And we think, again, it's very early, but we really believe that stem cells are going to help us find ways to deal with ALS. Now, there's not a person in this room, I would bet, who doesn't know a mother with a child afflicted with a rare disease. And it's so tragic because the populations of the patients is so small, hence term rare disease, that there's never enough research for cures and little hope for these families. And again, stem cell technology can really be an answer. Because if you think about it, 50 kids get this terrible rare genetic disease, we have the opportunity, we could find all those 50 kids and get their stem cells to turn them into their neurons or other cells to study, and then begin to test compounds. And we actually have done this already in a disease that's called INAD, infantile neuroxinal dystrophy, which is an ultra rare and fatal disease. It's really like childhood Parkinson's. So terrible disease, kids pass away before they're 10. And we took our AI platform, made the stem cells from a group of these children. And with, as I said, AI can see what the human eye cannot. We could see the difference between a healthy child of the same age cells and the kids with INAD. And then we took, the FDA has a library. The FDA has approved 3,000 compounds that are allowed to be used for treatment. And we tested each one of them using the AI to see if any of these compounds could move an INAD cell from this unhealthy to a healthy state. And we're really excited. We found 2 drugs that we think may work. And now we're seeking funding to take this to the next step. So it's really beginning to possible cures and so much relief to this mother. Many of you in this room really support cancer research, which is so important, and we too are seeking treatments for cancer. Now, sadly, our NICEF's visionary founder, Susan Solomon, tragically passed away from ovarian cancer a few years ago. And in her honor, we learned to use our unique stem cell technology to keep ovarian cancer tumors alive outside the body. And we get samples from doctors, and we're able then to grow these tumors into organoids, which we can keep alive for months. And this pioneering work allows us to test different chemotherapies on these tumors to get a sense of what could be successful to treat a cancer patient. And think about that. If we could actually save women from going through multiple terrible chemo, because we can figure out which one would be effective because we're testing it on their tumor in a dish, this would be an incredible contribution. And as many of you know, one of the new frontiers really in cancer treatments involves immunotherapies and really harnessing our own body's immune system to target cancer cells. One type of immune cell you may have heard of is called a natural killer cell, and it's particularly effective at targeting and destroying cancer tumors. So we have now taken stem cells, blood, and turned them into stem cells, and we've developed actual natural killer cells outside the body, and we're combining them with these tumor organoids of ovarian cancer, and we can watch how that natural killer cell attacks the tumor and learn so much more about these natural killer cells and how they can be used to move the needle in cancer treatments. One of the most important and really exciting contributions of stem cell technology will be making accelerating cures is actually to restore functions of the body that are lost to disease. So let me end with 2 exciting developments in what we call regenerative stem cell-based medicine that we believe will ultimately, we're just so optimistic they're going to eradicate 2 chronic, terrible diseases, dry macular degeneration and Parkinson's. So this year, NICEF is really excited to launch our first clinical trial, which is very unusual for a nonprofit. You usually see these, in pharma, but we're going to launch with Columbia University a clinical trial to combat this type of blindness, age-related macular degeneration, AMD, which occurs due to a loss of retinal cells, and vision starts to erode slowly, but permanently. And really a terrible disease, affects 11 million people in the US, and really, I'm sure everybody here knows someone that has AMD. So in NICEF labs, we have now drawn the blood of 6 AMD patients identified by the Columbia doctors, and we've created their stem cells. And we've turned these stem cells into their own retinal cells. And later this year, we're going to begin this groundbreaking clinical trial with these patients under the guidance of Columbia University's top retinal surgeon, who many of you may know, Dr. Stanley Trang. And under his guidance, your own cells, the patient's own cell, will be transplanted back into their eye. We've licensed a patch developed by the National Eye Institute. It's sort of a mesh scaffold on which thousands of the patient's own retinal cells that we've created in the lab will be placed. And we had to build a special facility known as a clean room. People are in hazmat suits. It's completely regulated to be absolutely safe because we're creating a cell that's going back in the human body. It'll go on the patch. Dr. Changwell's team will insert the patch in the eye, and then the patch will ultimately dissolve. And given the results of trials done with similar cells, we're really in different time periods and some with embryonic. We're really optimistic that that this treatment will stop the progression of blindness and stop the loss of the retinal cells. We are very secure that it's a safe treatment, and we're trying to be, not be too optimistic, but we're hoping we might even be able to see some vision restored. And what's really important here is that by using the patient's own retinal cells, the doctor does not have to suppress the immune system of the patient. And as all of you know, this is always risky, but certainly riskier as somebody gets older, which is the group that AMD most impacts. So there's more work and testing, but I really, I really see that this regenerative medicine, the replacing disease cells with healthy cells grown in the lab from stem cells, is truly the wave of the future. And to underscore that point a little further, let me mention the Parkinson's trial that one of our partners at Memorial Sloan Kettering is doing. Dr. Lorenz Suter has launched through his company, Blue Rock Therapeutics, a dopamine-producing neuron from stem cells in the lab. And these dopamine, that's what gets lost in Parkinson's. And this company is now finishing its first phase of a clinical trial. They were very promising, blood to stem cell to dopamine producing neurons and back into the patient. And the results were so good that the FDA said, we're going to let you skip right to phase 3, which is really cutting years and millions of dollars to get, and that's the last stage of FDA approval. So this truly is, as I said, a miracle of stem cells. And it's just, we're so advancing cures that I truly believe with this regenerative medicine that our grandchildren will routinely bank stem cells to create personalized cures in the future. We're not there yet, but you can see it coming, and it's actually really exciting for our grandchildren and for their health. Finally, it wouldn't be me if I didn't talk about education, my deep, deep passion. And at NICEF, I've been able to bring this, just this love to encourage and inspire the next generation of scientists through a range of educational programs. And when you're dealing with this cutting edge technology, it is really important to bring in institutions and students who wouldn't be exposed. And I can tell you, coming from a public university where we did a lot of great science, this cutting edge science was not being explored. It was so expensive, it was so modern, and it's mostly at the major medical schools. So to bring in New York City high school kids and college kids to show them this cutting edge and what we can do to cure disease really inspires. And I think, particularly in the New York City system, we need to model to kids what they can do and what they can learn and what the possibilities are. So during the school year, we host over 40 high school classes. Schools come, they spend a half a day in our labs. In the summer, we do a 2-week immersive for high school kids. And last year, we actually did a program with Prep for Prep where they sent some of their top students into our labs. We have college interns, and they are actually in the lab doing the experiments with the scientists and really learning the possibilities. And while many of them are in the labs, the other wonderful thing about our program is, if you think about your kids, grandkids in college, they may love science, but don't think, maybe I don't want to spend a career in the lab. They know they can do business development, they can do IT, they can do fundraising, they can do program development, they can do education and love science. So they see different career tracks that they wouldn't be exposed to. So last year we had a wonderful woman. It was very exciting because she came from CUNY's College of Staten Island, and she was interested in engineering, and she actually developed a hardware sensor to measure and control the ideal environment for our stem cells. So she took her engineering interest, applied it to a science environment. And then I'm very proud that when I was at Hunter, I had the pleasure of starting what's become one of the top early college high schools really in the country, and where the kids go on to Hunter College with 12 credits of college credits that they've already taken. That school's about 10 blocks from NYSIF, and it's called Manhattan Hunter Science High School, and we just made them our sister school. So from ninth grade, these kids, it's a majority minority kids, they're all going to be in our labs, seeing what our scientists do, seeing what our people do, and then each year they're going to have a more intense investment so that they're really, by the end, really truly versed in stem cell science. So I'm really privileged to be able to speak with you today and to really lead this extraordinary institution into its next impactful chapter. And it's an honor to talk to you and really ask all of you to join me in this exciting journey as we create NYSIF 2.0. So for those of you interested in science, we're really interested in your guidance. Where do we strategically direct our research? You know, as I said, we're doing work in autism, ALS, but we want to grow those fields. For health and pharma business folks here, we want to commercialize more of our discoveries. Why? Because it moves science forward, but it also brings in money to be able to put back in our labs for research. For those of you who are interested in education, we want to make this internship and fellowship and career development programs the best in the business and love advice. And then for many of you are connected to universities and medical institutions, and science is all about partnerships. Recently, someone introduced us to people at the Mayo Clinic, and we're talking to them. And so there's just so many ways you can't even imagine where you can partner with these other great institutions. So please, help us there. And we just, we really want to engage with as many people with as much advice, because we know with your help, we can get to the place where Alzheimer's, diabetes, Parkinson's, and macular degeneration are truly in the rearview mirror. So I will ask you to help us transform the potential of stem cells from theory to therapy to patients everywhere. I know many of you will come back to New York in late spring, summer. Please let Dale know, and we'd love to get in touch with you and give you a tour of our labs and engage you, because science is all about conversation and pushing an envelope to develop cures and make the world a healthier place. So thank you very much. So Dale, should I take questions?
That was a wonderful speech, and I hope you can give it to our new government. Because could you comment, please, on the freezing of assets of funding for research and the implications of it? And because what you have presented today, Jennifer, is awesome, and I think it needs a broader audience to really understand the critical importance of not stopping it.
Yeah, no, I think it's a question on everyone's mind. So I would love to step back, Ellen, and just because there's so much confusion about what happened. So as someone, again, both at NYSIF and at 22 years at Hunter, the government has this really interesting approach, and it's been very effective to fund science at academic institutions, right? So if I had a professor at Hunter who came up with a proposal to do this immunotherapy in cancer cells, and she would get $1 million research grant. And then Hunter, we had a 50%, when you hear that word indirect in the papers, we would get $500,000 in addition to the $1 million. Why? Because you can't do science in a vacuum. You need research administrators, you need the lights to go on, you need the laboratories to be clean, you need the updated computer systems. So the government was funding the infrastructure. And that's what this debate is really about, because otherwise the government would have to build massive research facilities in Washington, and they do. The NIH has labs. But the America, which is the pride of the world in biomedical research, and we have to maintain this, the government would have to otherwise do it themselves, but they turn to academic institutions and not even nonprofits like ours to do the work. So they're saying the scientists will do the work, and we will help you, institution, maintain the facilities, have the administrators for research, put on the lights, clean the labs, et cetera. I think, Ellen, somebody who worked in government such a long time and dealt with so many public budgets, I am not against conversations about can you do things differently. So I'll be really, blunt about that. So some of the things that are going on now, there's a conversation, there's no term limits on center directors at the NIH. So someone could be there for 30 years. Now, many people on both sides of the aisle say maybe 10 years should be a term limit. So I don't have a problem having a conversation about, should we think about what this $500,000 that CUNY got for this grant? Because I can also say, has for 22 years, not every penny was probably put in the most efficient way. So what's really wrong now is it's not a conversation. It's just a cut. And that's not tenable. So I think we have to get to a point where we're willing to talk about how we spend taxpayer dollars and be really effective with it. And we at NICEF will feel the impact. I mean, we have 2 federal grants, and we will be cut, if this goes through, $100,000, $200,000 in the next year or so, which we can't make up. So it's a very, very devastating. Well, we're still, it's more, we're doing that anyway. So for, again, and I think even everyone says, well, Harvard's so rich. I mean, Harvard is rich, but this is a lot of money that goes into science. So I think I'm all for a conversation that says, let's, remember Jimmy Carter had zero-based budgeting? Remember that all came in, and it was this idea that we should look at how we spend public money. And someone who I ran a city agency, public college, I think that's healthy to talk about using public money well. I really do. But this was too fast, too dramatic. It's not tenable to do it something like, let's have a conversation. Let's bring scientists from both sides of the aisle and talk about how much is spent, is it spent right, and let's look at it. But you can't do it overnight. So I think we're very lucky it's stopped right now.
But they're closing labs right now, so your research can be stopped. And that's
Well, I think, right, they stopped the funding is still coming, so because of the court cases. So right now we're in a pause, and there shouldn't be any labs really closing. So, hey.
Yes, hi. I've been following this closely for a number of years. One thing you said, I know people have been going down to Panama or Medellin and getting the stem cells. I think they're using the fluid from pregnant women's.
Still, yeah, some of them,
not
yeah.
the embryos, but the fluid. I'm curious, I'm wondering, you mentioned possibility the body's rejecting and having to do immunosuppressants. Is that more likely if obviously using someone else's than your own?
No, you're absolutely right.
How much more likely?
So it's a wonderful question.
I know people have gotten some really great results too, but I don't know.
No, it's a very interesting question because the stem cell field is sort of divided. So will always be more cost effective and an easier product to make one from a stem cell. We made that one dopamine producing neuron, and that neuron is what that Blue Rock has made their Parkinson's treatment on. So everybody in that trial is getting your neuron. Okay, so it's called allogeneic. So everybody's getting it. So therefore, you're going to have to immune suppress because you're putting something from my body into your body. We believe in autologous therapy, and every stem cell that goes back into your body that creates a cell is from your body, so you don't need to immune suppress. Clearly, it is more efficient to manufacture one person's cell for 100 different people. So people have sometimes challenged us because our method is going to be more expensive, right? So for each person with AMD, we're taking their blood, turning it into their retinal cell, and putting it back in their body. I have 2 real answers for that. Yes, it has to be expensive. But first of all, if you weigh the cost of care 24/7 for somebody who's lost their eyesight, you need to compare it to this therapy. The other is, the iPhone used to cost $300,000 to create one iPhone, and now it costs $13, right? So I really believe if something's effective, the engineering follows, and you get the price down. But it's that is one of the big debates in cell therapy. So the other piece of your question is again also very interesting. we feel very confident what we're doing. We're working with MSK, working with Harvard, the top places in this country. The FDA has taken very clear rules on what you can do with stem cells. That's why people are going to Panama, right? The science in this country, the regulation is really intelligent. Could we make arguments it sometimes gets too restrictive? Right? I mean, I remember, there's a piece in Walter Isaacson's book about Jennifer Doudna and CRISPR, where he reminds us why did the FDA come about and become so restrictive? And you will all remember it was thalidomide. It was unrestricted. It caused terrible impact. So thank God we have an FDA that's strict. But I can also make the argument, is it too strict, right? And that's what I think is going on. So we have real questions about some of this stem cell work that's going on in other places. Recently, the FTC, the government brought a case, and it was successful against some of these people that it had no basis in science. It was taking people's money, and it was really unfortunate. So this is one of those areas that I guess I would say to anyone thinking about these treatments, really do your research, right? Is it in Panama because the FDA is being too strict? Or is it in Panama because there really aren't results and our government is protecting us? And I think there's lines. So it's a really to be continued conversation, right? Hi.
Thank you for getting me to stand up. Anyway, a quick question and a compliment first. I love your speech because it
Thank you.
detailed in two areas where things were.
Thank you.
Can you do the same thing for depression and some of the diseases? Partly is to what's being done in the Army, but where are we with that in the same detailed description?
So I think it's a great question. What we learned with PTSD really said to all of us, wait, could this work in depression, right? Like, if we're learning that outside stimuluses can impact a cell, wow, or what we learned is the cells have a genetic makeup, right? So one of the things we're doing with the Michael J. Fox Foundation, there's a thought that there could be environmental causes of Parkinson. It won't be the only cause, but that it could be one of the added causes why some people maybe get Parkinson's from the environment. So we are now stressing, creating environments, things that mimic a harsh environment, like chemicals in the air and other things, and we're applying that to Parkinson's cells to see if what we can learn. So this is really the future. I think when we talk about stem cell research, creating from the blood to the stem cell, the process to the next is called differentiation. So we're making that stem cell into any cell. We have had the most success, I think universally, both in the beta cells in insulin and in neurons, right? So we do heart cells. We actually can see a heartbeat in a dish outside the body, but it's not as perfect as the neuron. And that's why I raised that question about the Alzheimer's study. When you imagine that you can take a neuron that we created from your blood, and then when you die, look at the neuron from your brain and see it was exact. So I feel because we're in a strong place with neurons, that what you're asking is one of the next steps, that we will be going into schizophrenia, maybe not sort of the normal like issue, what's a depression, but the real mental illness like schizophrenia, borderline, some of those things where it's clearly a genetic, we just know it's something genetic. I think we're going to use stem cells to address that.
Jennifer, hi. Fred Dicker. Thank you very much for your very hopeful talk.
Thank
Very
you.
impressive. I spoke to a couple of friends of mine who I think you're aware of. They run the Neural Stem Cell Institute in upstate New York, and they're in the final phase of testing AMD stem cell treatments. They're very optimistic about it. Now, I know your foundation is doing the same. So how do they differ? I mean, apparently both are very close to miraculous cures for age-related macular degeneration.
No, and I'm so glad you asked, because it's really interesting. Again, one of the things that's kind of, I think, beautiful about science is we approach the same goal. And sure, do you want to get there first? I'm not going to pretend you don't, but everyone really does cooperate and share. So Sally and Jeff are your friends and are a little ahead of us in a clinical trial to use stem cells to address macular degeneration. They too are creating retinal cells. Their approach is to inject the cells into the eye. and let them sort of, come out and go out into the eye environment. We think, could be right, could be wrong, we could both turn out to be right, that concentrating these thousands of cells on a patch and inserting them together in a concentrated form exactly where they should go, so you're not kind of guessing through an injection, our doctor, Stanley Chang, believes that is a necessary step. So we'll see in a few years, do we both get to the right answer? The other thing that's really interesting about what they're doing, it goes to the question here, is they are doing this allogeneic approach. They have taken one person's stem cell into a retinal cell, and then they have used that retinal cell for all their patients. So they will have to do immune suppression. Again, we're doing this autologous. We're taking your stem cell into your blood, into your retinal cell, into your eye. Again, way more expensive, right? And so maybe we won't get picked up by pharma because it's just more expensive. It's truly individualized personal medicine. It's your cells back into your body. More expensive than my cell back in your body. But we think it just has to be more successful, because you don't want to immune suppress someone who's 85 years old and just had a traumatic operation, right? So it's really interesting that a lot of us are on the same path, but in different approaches.
I wanted to
Oh,
ask
sorry.
a question.
Oh, sorry.
It's quite wonderful what you've given us, and it makes us optimistic about medicine and what have you. But I want to know what the we is. When you say we, I don't understand your foundation, what it implies, what it is, what you're really doing. I know you're doing exceptional work, but I'd like to know the nitty-gritty.
No, it's really, and as a physician, a great question, of course. So it's fascinating. We're a nonprofit institution, and we hire our own investigators. So we have the woman who does, for example, MS work. She's one of the top MS specialists in the country with stem cells. Her name is Valentina Fossati, and she's patented the Fossati method of creating oligodendrocytes from stem cells. So we have a great scientist in MS. We have a couple of great scientists in Parkinson's, diabetes, and the ovarian cancer work. So when I say we, it's our investigators. And I found it very interesting coming from an academic institution where scientists, yes, and it's different levels. If you're at Harvard and you're a scientist, God bless, you pretty much have to get these grants. And that's why, Ellen, this question of what happens at the NIH is so critical, because all of these institutions, as scientists, apply for grants. At Harvard, if you don't get a grant, you could find yourself not there, right? In different institutions, you have to bring in different amounts of money. I found it really interesting that we have attracted young scientists who don't want what is really security, right? You go to an academic institution, you get tenure, you're going to be there. Like, you're going to have a home. Our people are a little younger, a little hungrier. They didn't choose it. They didn't go to pharma. So they could have taken, I'm going to go to Columbia and be a diabetes researcher. I'm going to go to Merck and get a job in that lab and get paid more. They've chosen to come to us because we have this technology that is so exciting to them, right? And then so that's one group of the researchers. The other group of people who make up the we is fascinating because, as I said, we have a whole robotic platform that nobody else has. And we're making these stem cells from blood. Then we're differentiating them into neurons. Then we're bringing AI to read the neurons and understand them. Then we're testing drugs on them. So in that platform, I have software engineers, hardware engineers, biologists, computational biologists, data scientists. I think it was my third day on the job, and my COOs came to me and said, we have to hire another computational biologist. And I'm like, how do you even judge that? It's so ahead of things. So that's the we. There's a platform that does all this AI, makes the stem cells, creates differentiates them into different types of cells, puts the AI, reads the results, everything is imaged. So you have scientists 24 hours a day reading, the computational biologists, the data scientists, they're reading these images. And then a third, in the final group, is in this clean room, right? Where we had to build this completely sterile place. And it's interesting, we don't have an ophthalmologist on staff, right? Our ophthalmologist is the wonderful Stanley Chang at Columbia that we work with. Leading our AMD project is one of the top people in the field in manufacturing stem cells, okay? Like this job didn't exist 10 years ago. This is a job. And we brought him from a Canadian group that is really world known. And he has such an expertise in manufacturing cells that Columbia recently got a major federal grant. They're trying to do something with bone. And we had actually tried that once, and we actually closed that down because it wasn't being successful at that time. But they've asked our scientist that runs our AMD project to consult with them because he has such an expertise in how do you create a clinical grade cell that can go back in your body. So I hope that answers. That's the we. It's an unusual group. It's about 120 of us. So and I would say about 90 of those are in the lab.
And the funding comes from.
Really interesting. So it's three sources. One is philanthropy, which we've been incredibly lucky about. There's incredible people who really care about moving the needle because it's hard. You're not going to see a result tomorrow, as you know, as a physician. Second group are grants. So we get funding from JGRF is supporting our diabetes work. We're doing work with a Yale scientist in diabetes. I mentioned the Harvard partnerships. The Warren Alpert Foundation is working with us in Alzheimer's. So we spend a lot of money partnering with the disease foundations, and we also have a certain amount of NIH funding, a lot through partnerships. And one of the things, to Ellen's question, a JDRF, the Diabetes Foundation, now they've renamed themselves, if they give you $1 million grant, they will only give you $150,000 for that indirect. Okay, so that's one of the things, if you read that federal order, they quoted it. They said if the Gates Foundation and JDRF only give 15% indirects, why is the government giving 50? And there's answers. It's just, as I said, we need a conversation. So that was the second source. And then the other source is business development. So we have the best stem cell storage repository, one of the best in the country. So we store stem cells for other researchers. We also sell stem cells, right? So somebody, wants to, right now it's a grant really with Johns Hopkins, but we're making stem cells for their researchers, right? But sometimes a private group will say, we want to do diabetes work. We need great beta cells. You can produce them through this automation. They're amazing. We'll buy them from you. And then this, as I mentioned, the J&J contract is a huge deal for us. So this is a $5 million contract over 2 years for us to work with the J&J scientists, and they've come to our office, and it's real science, it's real sponsored research, but they're telling us what they want to learn in these neurodegenerative diseases, and we're using our platform to try to get to those answers. So it's a combination, and it's a challenge because science, as everyone here knows, because of AI, it's really become incredibly expensive to do all this. I tell a story recently, if you saw in the Times, Rockefeller University, Abby Rockefeller, about in the 60s, gave David Rockefeller, bought 2 Joan Mitchell abstract artist paintings, huge paintings, and she was just an artist. Now she's Joan Mitchell, and it's like she's one of the hottest artists on the market, and they have these huge canvases, and the president Rockefeller said, I'm selling them. And so people are like, outraged, oh, you can't sell art, this beautiful art in Rockefeller University. And he said, yes, I can. They're worth $32 million, and science is too expensive, right? So, I have to say, when someone who just finished a $770 million capital campaign can say science is expensive, science is expensive. So we're the little engine that could. We combine all of those sources to get where we're going.
Have you ever thought about having visits to your foundation to show them?
Yes, no, I think I ended my talk with, I would love to see every one of you when you get back to New York. We have lunch and learn sessions. It makes us really happy to open our doors because that's why we're doing this. We're doing this to move a needle, and we'd love to talk to you more about it. Please.
Yes, I have a question about further research with degenerative bone disease, joint disease. And I know they're already using stem cells for that. I mean, it's kind of a 50-50 chance of it helping or not. What do you see for the future
Yeah, so I think you're right. It's if it, you hit it on the nail. It's this one's a tricky one in terms of actually how the stem cells are turning in to the tissue and bone that could actually regenerate. And as I was mentioning, it probably was about 5 or 6 years ago. It was a while ago that we were doing this research, and we weren't seeing the results. We weren't feeling like we were moving the needle. So we really like to be nimble and say, look, we're making a difference in diabetes. We're making a difference in Parkinson's. We're going to make a difference in AMD. So we shifted our resources there. But then, as I said, the federal government has just given a huge grant to Columbia for doing this kind of work in bone. And we're there, literally, they called us, they said, you are the best people in understanding how to make this human grade, this clinical cell, and we want you to work with us. So it's going to be very interesting to see if Columbia gets better results than we were able to get. And then I think we'll all, that's what I said, science is great. Then we keep building on what they learned. But you're absolutely right. This one's, some things are better. Like the neuron, as I said, we're doing a great job in creating neurons in a dish and learning, right? So that's one of the reasons we're pushing so hard there. So,
Now,
hi.
autism has increased fourfold in the last 2 decades, and today 1 in 36 of our children are suffering from autism. Does your AI show you where it started from?
So it's a great question. So I'm also, when I was at Hunter, I worked mostly in the area of the people with children with autism. And we started actually a master's program to train teachers to deal with the severely disabled autistic kids so they could actually go out to dinner and be sort of more functional. So I've spent so much of my life working on helping people with the affliction that I want to be able to come back here next year and tell you more. Like right now, we're very proud of making these cells. And the Simons Foundation, as you know, Marilyn and Jim Simons are big supporters of autism. They had a child with the disease. And right now we're sending our cells out for researchers to look at exactly what you mentioned. And no one has yet come back and said, we really see the biology in this cell. But they couldn't even be having that conversation if we didn't make a stem cell from a person with autism and send that neuron to that researcher at Johns Hopkins to look at it. So I think this is a stay tuned, and I agree with it. Terrible affliction, it's growing. We have to help people who have it, but we have to figure out a way to not continue the crisis there. So thank you very much, everybody. It's so wonderful to be here.